Hello guys and welcome back. So the main thing that I want to set up here is when we look at this, we cannot have multiple sources per curve and have them all emit at the same time. If we do that, we will end up with a huge sim. Let's say this guy needs 10 million, this guy needs 10 million. We cannot sim that at the same time. We need a way of separating this so that we can process each curve separately. So what I'm going to do is I'm going to fuse these guys. If there is any intersection, we can if there is any overlap, it will combine the curves. Hopefully they're still separate enough for us to work with. Yeah. So let's do a color node and randomize the color by primitive. So random. And you can see we have a curve for each one of these guys. We have a unique color for each one of these curves. Okay, and some of them are not reaching the end; they're matching with this. So these two guys, this guy is not hitting the end goal, so it needs to work with this curve that is next to it. And if we take a look at these guys, they all work nicely together. These guys, they all work nicely together. Maybe this and this together, this together. So let's see if we can find a way to cluster them. Okay, and what I'm going to do is I'm going to create a, let's see, let me think. I'm gonna use the same thing. Still have that. Let me check something. So I'm gonna use the same group node that we used to group the center. And this guy, yeah. So we have, we're grouping those points. So let's delete everything except those points. Cool. And let's add an add node, delete geometry, but key points. Now we have all the curves emission. We're just we're hacking that in. So I'm going to use a cluster node that can group things based on their location. Okay, and I'm gonna leave it. I'm gonna leave the default. And if we take a look at the cluster attribute, it's now created and it's an integer. So let's create a color node and visualize this cluster. So point random from attribute. I'm going to use the cluster attribute. And if we zoom in, we see that it did a great job at grouping them nicely. So these guys could go together, this one. So it did a great job at finding what works together and what not. We can tweak this nicely. So what I want to do, I want to group these curves not by, I want to cluster them not by their location, but by the location of their points at the top. So for this, we need an identifier. We need to be able to track these points and then copy this the cluster information back to the curves. So what I'm going to do is I'm going to create a triangle node. I'm going to create an attribute called original called curve, and this curve is equal to @primnum. What it does is, if we take a look at this attribute, each primitive has a unique attribute. Okay, each one of these guys have a unique attribute, and now we're just copying that attribute back to the points. Okay, so let's continue our thing. We're deleting the points, we're clustering them. We have cluster attribute ready. So let's do this. I want to copy that cluster attribute back to the points. So I'm going to use attribute copy. I want to copy geometry to copy to is this. Okay, and the geometry I'm going to copy from is this. What do I want to copy? I want to copy the cluster. And this match by, I want to respect the what did I call it? Curve? Yeah, I want this guy, the copy process, to respect the curve information. So let's hide this color and let's copy this node back and run it again. And this time, let's see here, cluster, match by attribute. So curve is correct. Yeah, it should work. Okay, so this is the copy from, and this is the goal. Let me check this quickly. So it was working when I copied the curve attribute from here. I copied it with a space, and when I paste that, it added a space, and that's something Houdini recognizes. So I simply deleted that. And now the curve attribute, the cluster attribute from these points, from the root, we've copied that back to the curves. And now if we run the color generation based on the cluster, we get this, which is very, very cool. Now see these guys, for example, they're clustered together. We want them to be with this. These two guys are separate. They're together. We can play with the cluster attribute, so we can reduce the number of clusters, for example, like that, and that will make generate a better result. Something like that. Cool. So it's just this guy here. And I'm not gonna worry. Not gonna worry about that. Actually, the short guys, I'm not going to worry about them for now, because we only need them to emit here, and then once they reach that, the intersection is not going to be very visible, because the main flow will be coming from here. So even if this guy emits up to this point and then stops here, it's fine. It's not going to be critical. And to simplify the process, I'm just gonna delete these guys, and now we have a proper clustered curves. And the idea is, I'm not gonna do the whole setup. I'm just gonna explain the idea. So we want to do, we're going to separate these curves a cluster at a time. So I'm going to use this syntax at cluster is equal 0. And this expression, if it's true, it's going to keep the curves where this information is correct. So let's say delete non-selected primitives points, sorry. And now we have this, that's cluster number 1, and we can drag this, and every time it's going to show us a specific cluster. Okay, so the other thing that we have is, we also have, where is it? We also have the start. So that group is there. And with this, I can do blast. Start, delete non-selected, and now I have the starting point. Okay, and I'm gonna create a circle. Again, I'm not going to do the full setup, but I will explain the full workflow. I'm going to do a copy 2 points. And now we should have 3 spheres. Nice. I can scatter them with points. And these are, this is going to be my source. Okay? And this is going to be the goal. Now, as you can see, these guys, they're not oriented properly, and what we need to compute is we need to compute the normal vector. In this case, it could simply be from here to the center, and that should work, but we can also compute the more accurate version of that, which is the normal, the tangent. And I'm going to turn this off and store the tangent as the normal. So if we take a look at the normals now, we see a curve, the value is aligned, and now the circles should align perfectly, okay, with the curves. Okay, let's create a pop network. It's going to be my source. This is going to be my second input for the curves. Let's dive inside. Let's do a pop curve. Use the second input, set it to 1, and let's hit play. Nothing. Let's change this to all points, and something is happening. So you see we have all the curves going. And now once we have the setup and we're happy with the result and everything, we want an automated system to allow us to work on the other curves quickly and easily. Okay, so let's go back here. Now I meant to change the follow scale, maybe these two, set to 2, just to have something. Okay, cool. So we have something happening. And what I want to do is we want to automate the system so that we only work on one of them, and then we can simply change this to 0. Hit run, and everything works. Cool. So we're gonna set that up so that we have a switch system that automatically can switch the inputs based on the SIM, based on the caching process. So we'll do that in the next video. Thank you guys for watching, and see you in a bit.